Let's look now at how we can use our knowledge of equivalent fractions we gained previously. What we established in the last video is that we can generate another fraction which is equivalent to this by multiplying both parts by the same number. For example, multiplying both parts by, that's right, by 4. Let's just remind ourselves why. Here is a whole one, which I'm going to split into 5 equal sections. And I'm going to colour 3 of those sections. So this fraction here is 3/5. Now, what I'm now going to do is show you how this fraction is equivalent to this fraction. So, multiplying both parts by 4, what does that do over here? Essentially, that means the following. Look at what I'm doing. I've chopped each section into 4 equal pieces. Now there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20 bits in total. 4, 8, 12 of those are shaded. So, we now can look at a fraction like 5/7, and if I said to you, give me another equivalent fraction, you could probably do that. Come up with one now. If you said 10/14, well done. 15/21, 20/28. Perhaps some of you are more ambitious and said things like 50/70. Multiplying both parts by 10. This was by 2. This was by 3. This was by 4. This is by 10. We also talked in the last video about the following. If I had a fraction like 50/70, I can write another equivalent fraction which does not have a bigger numerator and denominator. In fact, it has smaller numbers. So if I'm given this equivalent fraction, this fraction here, I can say that that is equal to 5/7. Now this isn't multiplying both parts. What is it doing? Good. Well done for spotting. It's dividing. Because multiplying and dividing are what we call inverses. The word that sometimes you'll hear is opposites. So they go together as a pair, multiplying and dividing. Now, this process here of making the numbers smaller, of making them simpler, of simplifying, is much more useful than making the numbers larger. Take, for example, the following. 91 out of 182 countries vote for an extra day's holiday. That's hard to say, but 91 out of 182 is actually your favourite fraction. It's just in disguise. 91 out of 82 is a half, because both parts, when divided by 91, work like so. Now, let's try doing a few of these simplifyings to see if we can get the hang of it. First thing I do, take a look at the fraction given to me. What times table are they both in? I've got to try and divide both the numerator and denominator by the same number. Well, I think these are in the 5 times tables. Let's divide them both by 5. Drawing the arrows will help you to see what you've done later. So 15 divided by 5. 5, 10, 15. So that's 3. 20. 5, 10, 15, 20. So that's 4. So 15 over 20 is 3/4. If writing out the times table helps over here, do that. Let's look at another one. Now, I'm going to try and simplify this. So I'm looking for a way of dividing both numbers. Well, I can tell they're both in the 2 times tables. Can you explain why? Good. If the last digit, the units column, is an even number, it's in the 2 times tables. So if it ends 0, 2, 4, 6 or 8. So how many 2's go into 18? 1, 2, 3, 4, 5, 6, 7, 8, 9. And what about 24? Well, let's carry on from here. That's 10, 11, 12. So we have simplified that. Look at it for a moment though. I think there's something we haven't done. This is simplified. It is not simplified fully. Look at 9 and 12. What can you see? Well, they're both not in the 2 times tables because 9 is an odd number. What's the next times table we should check? That's right. We should check the 3's next. 3, 6, 9, 12. There they both are. So we can simplify it again by dividing them both by 3. 9 divided by 3 is 3. 1, 2, 3. 12 divided by 3 is 4. 1, 2, 3, 4. So what we have to be careful of here is making sure we have simplified fully. Now, some of you will have noticed 18 and 24 at the beginning and looked at them and gone, they're both in the 6 times tables. If you can spot that straight away, you can divide them by 6 straight away. If you can't necessarily feel confident you've spotted it straight away, find any number that goes in and then keep working your way down. Let's try one more harder one. Okay, what's the number we should start with? Good answer. Always check 2 first, and the answer is they do. So divide them both by 2. If you're not confident on that, let's have a look at it over here. 2's into 1, doesn't go. 2's into 14, 7. 2's into 4, 2. 2's into 1, 6, 8. 2's into 1, 0. Carry the 1. 2's into 16, 8. 2's into 8, 4. Let's go again. Aha! They're both still in the 2 times tables. So I'm going to divide them both by 2 again. But wait, they're still both in the 2 times tables. This is going well. What do you notice now? Not in the 2 times tables. So what should we check next? That's right, we should check the 3's. 3, 6, 9, 12, 15, 18, 21. There they are. 1, 2, 3, 4, 5, 6, and then 7. And that is how you simplify.